Hi, hello everyone. In last video, we left off with these sprites, and this video I promised to deal with this issue of background here, which is white. So for those who are just joining, you can either follow the video from the very beginning of the videos, or you can easily just find this code on GitHub, which will be also in the description of the video. But let's get to our problem and how do we solve it. So here, for example, you can see the white background here. And what's happening here? It's actually really simple because we don't have color blending enabled or alpha blending enabled. What happens is our original image has value of 1 here for alpha, but in these edges it has value of 0. Therefore, this gets set to 0 and it's actually leaking this background color here. If I just change the background color, you might see what's happening here. And the thing is, let's just do that. So maybe I can say this body style, background color, red. And you can immediately see the issue here, right? It's leaking this background color because this value here is for alpha 1. For example, but you might also see it here, right? We had our gray color here. If I set it to 0, immediately we have this, right? So let's just return it, and let's return our background here. So how do we actually solve this alpha issue? It's actually really simple because the WebGL already has a method for it. So we can just say this GL enable, this GL blend. It's still not solved, and that's because we also need to specify how do we solve that blend via blend function. So we can use this GL blend function, source alpha, and then 1 minus source alpha. And I'm going to explain that in a second, but you can already see that we get kind of better result here. And how does this actually function work? So if you look at the arguments here, we have S factor standing for source vector, and then we have D factor standing for destination vector. So how does that work generally? So let's say we have our source, and source, okay. So we have our source, and source will be this image, for example, here, and we're blending it with big background. We might blend it with this, if this is drawn first, and then this needs to be applied over this, but we're just going to focus on background now because it's a bit easier to explain. So we have our source, and let's say that we're looking some pixel here, all right? So we'll be looking at these pixels here, but we also have this idea of plus destination, right? And destination is this color that we're blending with, which is this background, right? So we're applying this spaceship over background. So this will be destination, background, and source is our spaceship. So we also have this idea of factors here. And what are factors? Well, we basically multiply our source with source alpha. So we can say here, for example, source alpha. And we have this idea of 1 minus source alpha, and that's destination vector. So it will be 1 minus source alpha. So how does that work? Well, if you take a look at image here, let's just we have our source, and source alpha here is 1, right? Because here it's 1, here it's 1, here it's 1. But in these small corners here, because it's PNG, right? Alpha is set to 1 to 0. So we're looking at these ones here. So we're going to have our source times 1 plus destination times 1. What was our source alpha, right? We're looking at some pixel here. It's 1. So what do we get actually here? Well, source times 1 is just a source. And plus, so we have 1 minus 1, that's 0. Destination becomes 0. It's source plus 0, and we're just left with source. Therefore, our original image is kept. Okay, but take a look at the other scenario. So let's say we're also looking at this, but we're looking at this pixel here. Okay, I need to freeze this. We're looking at some pixel here, and here source alpha is actually 0. So we had our source times source alpha, which is now 0. And then we had also plus, this is actually multiplication, and then plus destination multiplied by 1 minus source alpha. What is source alpha? It's actually 0. So what are we left here? Oh, well, this here is 0, and 1 minus 0 is 1, and 10 times destination is destination. So therefore, our destination color is kept, or destination alpha in this case. So therefore, here the original image is applied. Sorry, image from our back buffer, which was this gray color. Okay, that solved it. So hopefully you understand that. That's kind of very important, and you can really work with this. If this ever confused you, I hope that this explains it. Second part of this video will be actually just refactoring, so that we can optimize stuff. So let's just start refactoring some minor stuff, and let's start with. I can enlarge this because we're probably not going to look at background for a while, so we can just move these methods first. So I'm just going to cut them. I'm going to create class buffer util, and then just export class buffer util. And here, actually our GL is now going to be pasted in, and here as well, WebGL2 rendering context. And in Visual Studio, you can press Command F or Control F, and then it will open this find. And if you expand it, you can just say this GL, and then replace it with GL. And that should fix all our errors here. And let's just make these methods public, static, as well here, public, static. So let's just use it in our renderer. Let's import that. Import buffer util. Okay, and then we have to fix it here. It's buffer util, and then the first argument now is actually GL. So we need to fix it here as well. This GL. Let's just see if it works. It works. Perfect. Second thing that we're going to refactor is we're going to pull this create shader and create program as well. So let's just copy that. Let's do this. So I'll just call it program util ts. Export class program util. We're doing the same thing here. Let's just replace occurrences of this WebGL, and then let's just paste our WebGL as rendering cortex. This will be public static. Here public static, and the first argument is and then let's just format it. Okay, done. Let's import program util, and then we're going to use it here, here, and here, and we just need to pass this GL as first argument. Alright, now it's a bit more readable. Okay, and the next thing that we're going to do is to actually create another class, which is just going to be called, let's call it Sprite Renderer. And let's just say export class Sprite Renderer. It's going to have constructor, GL. Let's just say private. GL WebGL2 rendering context and width. Just style number. Sorry, it should also be public. And then we're going to do same thing with, or private, better yet. I don't want to expose that, there is no need. Height number. Let's do this. And then let's just have public async initialize. So now we're going to have our sprite render, and here we're actually going to clean up renderer, and we're going to take all of this and we're going to move it to sprite renderer. And then let's just organize this a bit. So this content initialize can go here. This is fine. And then let's just take all of this, move it to sprite renderer. And then this draw sprite method as well. Now belongs to Sprite Renderer. And we also have, so we're going to move this and camera update methods. So, but we're actually going to have public begin. We're going to move this here, camera.update here, and then we're going to have end, which will be here. So we need to resolve, let's see. You can just add all missing imports. So make sure that everything is imported. And here we're actually going to create our sprite renderer. So sprite render, this is fine. And then sprite render initialize, and we're just going to await it. Now everything is broken, and we're just going to set this here, the sprite renderer. Okay, let's see what's wrong here. So this width here, this height here, and we just need to clear these things here. And something is wrong. Sorry, we just need to call this sprite render begin, and then we can say here this sprite renderer that end. Okay, perfect. So that's it regarding refactoring. I just realized I forgot one small tiny bit of detail here with the alpha. If you take a look here, you can see some white color protruding here, so it's kind of at the edges. So let's just deal with that as well. So if I do this again with background color, you can see it a bit reddish here, and that's because these smaller edges have alpha set to 0.2, 0.3, anywhere between 0 and 1. So how can we fix that? Well, we can just disable. So now in our render, we can just say to our context, just don't use alpha here, and then this should be solved. If we just don't use alpha for our, well, basically, usually, so it might be something. Usually, if you work on desktop, usually for let's say window, you just have R, G, and B, and you don't have to deal with alpha. But on browser, it's alpha is used by default, so you have to deal with alpha as well. But the issue here is, for example, if I don't have I have alpha false here, and it's sprite render. If I just disable blending, you can see black color here. So this will be usually the case on desktop, where you don't have to deal with this background alpha of canvas element. Anyway, so you can do this small thing, and it will sort this thing out. Also, what I want to discuss is the following. So I do recommend that you install this extension to your browser. So it's called FPS extension, and then you can enable it, and you can track FPS here. So for now it's 60 frames per second, that's fine. But if I just do one small modification, so let's go to our renderer class, and if I just do one small modification here, I don't need this. This will be, let's just do this as well. Let's just loop it 100 times here and put this code in our loop. And just to make it clear here, let's do this. Random times this canvas width, and here for height we're just going to do that as well. This canvas with height. Okay, you can see this effect here. So we're just randomly changing position of our spaceship. Let's just do this for this ship as well. But that's not that important. What's important is just look at our frame rate. This is just so bad, and so this we will deal with this actually in the next video. So the point here is our sprite renderer is just it's so bad, it's unbelievably bad, and we want to fix that. So that's what I'm going to do for the next video. My goal is to fix this rendering so that it runs 60 frames per second and not 35. It's even stuck here. That's how bad it is. But also one small detail that I wanted to do before we end. Let's just finish cleaning some stuff up. Let's just delete on all unused imports, and let's just call this class now engine. And let's rename here engine as well. Update imports for engine. Yes, always update. It doesn't work, weirdly enough, because it's not saved. Alright, so that's it for this video. In the next video, which I hope to do shortly after this one, we're actually going to finish our sprite render class so that it really is fast when it comes to rendering sprites. And I'm going to also explain why this issue is and why is it so slow. So hopefully you enjoyed this video, and until next time.